Struggling with GATE computer science? Find out the secret to crack it from the toppers.
Ravi sir was the one who crafted my success. His strategy of teaching concepts from scratch made my understanding so strong that I could conquer any question.
Ravi sir motivated me every day to keep going and keep learning. It is because of him that I overcame all obstacles in this journey.
I remember him saying, CS stands for common sense, and that one line completely changed my approach towards the subject.
Being a working professional, I didn't have to spend additional time figuring out what to study. Just watching Ravi sir's videos fully equipped me to crack the exam. The secret
To my success
In GATE is
Ravindrababu Ravula,
sir.
Many success stories, many more waiting to happen. Learn live from Ravindrababu Ravula, only on Unacademy.
Okay. Hello everyone. So we are continuing our standard template library sessions. So just for a review, let's revise whatever we have done so that we are on the same page, right? So we are doing a course on C++ language, and in C++ we have basics, object-oriented programming. We have done these things. So basics and object-oriented programming will be useful in your interviews, in your placements basically. So there will be an MCQ round. I have told you. I have told you before also. Okay. So there will be an MCQ round where generally programming specifications are asked. Okay. So any programming language can be asked, depending on what company uses which language. So yeah, depending on that, questions will be asked. Okay. So if you are sitting in an Oracle interview, probably Java questions will be more, and so on. Cool. So anyways, okay, mainly the object-oriented features are same in C++ and Java. Okay, there is no major difference. We will see. So Java lectures are also going on. Sir is taking them. You will see. Okay, so if you finish C++ and Java, it is basically enough. Okay, so no more language will be required for interviews. So basics we have done, object-oriented programming we have done. Then we started standard template library. Okay, STL is standard template library. Okay, so we exactly know the meaning of this. It is a library containing all the class templates present in the standard namespace. Library containing all the templates in the standard namespace. Okay, so it is very important. In all the programs which I write, I use this line using namespace std. Okay, so if you are not using this line, the containers or the algorithms or the iterators which we are seeing won't work. Okay, they all are present in the standard namespace. Even cin and cout are present in standard namespace. Okay, so this line is compulsory for competitive programming. You can think of it this way. Okay, otherwise you have to write everywhere. Before vector you have to write std. Okay, you have to resolve for the compiler that vector is present in standard namespace, cin, cout are present in standard namespace. Everything you have to resolve. Okay, even today we are going to start algorithms. Okay, so all the algorithms are also present in standard namespace. So everything in this standard template library is present in standard namespace. So that's why we just write this one line. So every code which I give in these slides, you can just imagine that this particular line is present in the code. Okay, then this will work. Okay. Okay, so we were doing standard template library. In a STL there are three things: containers, iterators, and algorithms. Okay, so we have seen already what iterators are. How do you create iterators? What type of iterators are there? For which container, which type of iterator is created, and so on. Okay, we have seen everything related to iterators. We have seen some demo for iterators on vectors. Okay, on vectors we have given demo also. I have given the demo on cline ID. We have created some iterators. I have shared the code also. So I have shared the code in this Telegram group for the demo. So if you have not joined this, you can join the group. Here I'll be sharing the files, the demo related files and so on. Cool. So we have done iterators. We have done demo on vector. So vector was a container. Actually there are many containers. We will see them one by one. So for these 2 days, today and tomorrow, we will discuss some of the algorithms. Okay, not all. Let's say 40% of algorithms will be covered today and tomorrow. Okay, after that we will again see some of the containers, then we'll continue algorithms. Okay, so containers and algorithms will go parallelly. So by this month end, you can expect to finish that we will finish both containers and algorithms, all the generic algorithms and all the generic containers that are present in standard template library, okay? And in detail, we will do demo for every function, and I'll explain you every function which is present in container, okay? So some of you told me in the first lecture, I remember I have seen some comments that I have not taught you for each, okay? So actually for each is a generic algorithm. So we have not started generic algorithm, that's why we didn't have this for each thing, but it is present in generic algorithms, and today we are starting generic algorithms, okay? So we'll have small lectures, 30 minutes each for algorithms, and in this lecture we are going to see the first and the most important algorithm which you are going to use in almost every program, okay? Sorting, okay? So sorting is very basic, okay? Actually what happens is, in competitive programming question will not tell you to sort an array or to sort some integers. It is your duty to think of a question and think of a question as a puzzle, that how and how you can solve this puzzle basically, okay? You have to think, you have to make a chain. After reading a question to the correct answer, you have to make a chain in your brain, that how basically can I solve this question. And generally it happens that most of the ad hoc problems which I talked about, cakewalk or ad hoc problems, they involve sorting in one way or the other, okay? We will see many questions, but sorting will be a key part, it will be an integral part of the questions in competitive programming. So in one program only you might require to sort many vectors, many lists, or you might want to sort other data structures, okay? So when I say sort a vector, it is not necessary that you have to sort a vector of integers. Right now I have given you all the examples for vector of integers. What happens is you can create vectors of vectors. Okay, you can actually create vector of vector. So in that particular vector, each entity is itself a vector. So it is like a 2D array, and that too dynamic, okay? Because every vector can have different size. So what happens here is, this vector is a special type of vector in which every entity is a vector, okay? So every entity in this vector can have different sizes. So we will see, when we see trees and graphs, we will be representing graphs as vector of vectors, or you can think of it as 2D arrays. But 2D arrays have fixed size, like 5 cross 10, 10 cross 15 and so on, okay? But here it can be dynamic. One row can contain two integers, the other row can contain 15 integers and so on, we will see. So this is very famous adjacency list representation of a graph, we will see. So in most of the graph problems we will be using adjacency list representation, we will be using vector of vectors, okay? And it might be the case that you need to sort a vector of vectors, okay, on any criteria. Let's say first element of every vector, you want to sort this entire vector based on the first element of the vector contained in it, okay? It is not very easy question, you cannot do it in 2D arrays, okay? It is very difficult to do it in 2D arrays, but when we come to standard template library, when we create vector of vector, it is very easy actually. We will see today that how we can sort the containers. And sort, heap, stable sort, these are generic algorithms, okay? These are generic algorithms, they are created on iterators, they are created on random access iterators, okay? So any container which supports a random access iterator, you can sort it using the same function. So their arguments will be iterators, not an object of some container, okay? They are not created specifically for one container and not for the other, they are created using iterators. So today we will see the bridge between containers and algorithms which are iterators, okay? So algorithms will be using iterators. So in the syntax of these algorithms, sort, and in the next lecture we will be seeing upper bound, lower bound, binary search, everything. They all be using iterators as their arguments, okay? We will be seeing that. So yeah, this is about that, and you can ask doubts if you have any. Meanwhile, Udit, I know actually the theoretical concepts have not been completed for list sets, okay? We have not covered lists and sets yet. Vector, the theory video has been completed, that's why we have done demo. So day after tomorrow we will do list as well, okay? So we'll start again containers. 2 days we are seeing all the generic algorithms, okay? The third thing. So there are many generic algorithms, we are doing that. Atishay, have you solved the long challenge problems? Okay, firstly you need to solve the long challenge problems. Firstly we'll discuss that, then we'll move forward. Okay, try to solve one more additional problem, then we'll discuss. Actually that the posting the problems is long due, I know. I have to post them, but I'm not getting time. Okay, I'll post them because we have to plan sessions for discussing them also. If I give you some questions, I have to plan sessions to discuss them also. So right now my aim is to finish STL first, then we can go to practice problems. Meanwhile you can do long challenge, and shortly cook off and lunchtime will also be there, so you can participate in those contests as well. Okay, yeah. So let's start with first set of algorithms, sort and stable sort. Okay, we will not be seeing sort heap in detail, it is very easy. Okay, so we will see. Okay, let's start the first set of algorithms. Sorting, we will be applying the sort function many times, so this is very important lecture. Okay, coming to standard template library. So this is the Telegram group link. If you have not joined it already, you can join it via this link, t.me/uncodecp. You can search the group on the Telegram app. You have to search Uncode CP, you'll find the group. Okay, and before starting, so there is a surprise event launch. So this might be the best batch you were looking for. So in coming if after 6 months, if your interviews are going to happen, or in the coming six months, if you are planning to switch the company, switch your current company, and if you want to join some product based company, so new batch is going to launch on 23rd. Okay, 23rd of March. So you have 3-4 days to decide, and the batch name is placement 2.0. Okay, so one batch has already happened for the placement practice, and another batch specifically for placements is going to happen, and it is like a crash course. So in 4 months, in just 4 months, all the generic algorithms that might be asked in placements will be covered. Okay, this batch is not for competitive programming. So if you're not if you don't want to be an excellent programmer, okay, so I have told you, so for placements, very high level programming is not required, very high level data structures algorithms are not required. So only that is required for any product based company, that is 5-star or 6-star programming in CodeChef. Those concepts will be covered in this batch, and in only 4 months many practice problems will be solved. So actually this batch is exhaustive, coming to all the content that is required for placements. Okay, puzzles, aptitude and coding, everything will be covered. So it is going to start from 23rd March, and in just 4 months all the placement related things will be covered. So if your target is just to get a job in next 6 months, so you can apply for jobs after 4 months after finishing this batch, and yeah, you'll definitely get one. Okay, so yeah, so this batch is for 4 months, and I'll tell that who will be teaching, who the educators are, and we'll discuss that at the end of the slides as well, the content as well as the educators. Yeah, so Vertex, Triumph and Ascend are already going on, we have discussed these, and this is the new batch which is going to start on 23rd. Okay, so let's start the sort function. So Rutuja, my slides are red, that's why I am using red pen. Okay, so my slides are white background. Okay, cool. So this is the this is how the sort function looks like, just the word sort. Okay, the function has the name sort only, and this is the template. This is the syntax of the sort function, and I have told you before also, but just by seeing the syntax of any function, actually you can go to the C++ manual and type and search for any function, and standard template library functions are also present in the manual, and there the first line which you will see is the syntax, and just by seeing the syntax you can infer many things about a function. So actually it is not specifically a function, it is a generic algorithm. Okay, so so this is the syntax for sort function. There are two syntaxes, first is the default syntax and second is the custom syntax. We will discuss both of these. So what happens here, so this is the syntax. Okay, so what do you think, what type of function it is? Okay, we have defined a template, so it is not a function, it is a function template. Okay, sort is not a function, it is defined as a function template. Okay, you can see this void sort, and these are the arguments. So this is the definition, this is the declaration of the sort function, and since we have template also before that, So this is exactly the syntax for writing a function template, okay. So all the generic algorithms are written as function templates. Why? Because any type of iterator can be passed to it, okay. An iterator of integer vector, an iterator of a string vector, an iterator of a list, an iterator of a queue, all of any type of iterator can be passed to it, right? And it should be able to handle those iterators. So that's why they are implemented using function templates. So depending on the data type which you are passing, depending on the iterator, it will take different forms, and it can actually be used for any type of container. That's why. Fine. So this is our sort function, and so yeah, when we write class random access iterator, so this is the type, okay. Whatever we write after class, this is the type for the template. We have seen this. So when we discuss template, we have seen this is the syntax, right? Template class t, and then our function, whatever the function is, and here you can use t as a data type, okay. So every occurrence of t will be substituted by one particular data type. We have seen this. So here this type t is random access iterator, okay. So what happens? Here is the type. So first iterator is of type random access iterator, second iterator is also of type random access iterator, okay. So you have to pass two random access iterators to it, and those random access iterator can be of any type. When I say type here, I mean they can be of integer vector type, they can be of string vector type, they can be of string queue type, okay. They can be of any container, but they should be of the same container, okay, because we are using the same type here and here. Do you understand this thing? We are using the same type here and here, so both the iterators should be of same type. If you got this point, just write in the chat box. If you have seen the template lecture, then it will be very easy, okay. Just think of random access iterator as t and substitute this with t and this with t. So what happens? The first argument and second argument should be of same type. This is what this statement is saying. Cool. So yeah, this is the syntax of sort function, okay. You have to pass it two iterators, and what it will do, it will sort everything between this range, the first iterator and the second iterator which you pass. So you have to pass two random access iterator to the sort function, and it will sort everything between it. Very simple, okay. We know vectors. We have to pass two iterators to that vector to the sort function, and sort function will sort everything between this range, and it is guaranteed that this sort function will take n log n comparisons, okay. So any comparison based sort cannot be better than this. So we will do the proof of this thing later in algorithms, but you cannot do sorting better than this, okay. You need at least n log n comparisons. If you know algorithms a bit, you might know this thing. So this is the most efficient method, okay. So we don't need to know the algorithm which is written. This is just the syntax. So it has no return type, okay. It has no return type. So you just have to call the sort function and pass two iterators to it, like v.begin, and let's say I pass v.begin and v.end. So this is the most general line which we will be using, okay. We can sort a vector, an integer vector using this line. I have passed two iterators, okay. We know that what begin and end do, okay. So this is the beauty of this course, okay. Now you know every specific detail, every single thing written in the code. You don't need to remember anything, right? You exactly know what v.begin does. It is an iterator pointing to the first element of the vector. What v.end does, it is the iterator pointing to the next element to the last element of the vector, okay. We know this thing. And when I pass this thing, it will sort everything between these two iterators. Yeah, so number of comparisons and time complexity is same, okay. Yeah, so the time complexity is n log n. So it will be the fastest way. So you don't need to worry about anything. You just have to write this thing, and the sort function will work most efficiently, okay. And there is also another function written. It has 3 arguments. So this sort function has 2 arguments. You just have to pass You just have to pass 2 iterators, okay? So by default, this template, the first syntax, what it will do, it will sort the vector in ascending order. Okay, it will sort the vector on any container in ascending order. But if you want to do some other functionality, okay, if you want to sort in descending order, or if you want to sort, so when I said vector of vector, when we discuss vector of vector, let's say I want to sort this vector of vector using the second element of each vector. Okay, based on the second element of each vector, I want to sort this entire vector. If you want some specific sorting techniques or some specific sorting implementation, for that we have second syntax. Here we have 3 arguments. 2 arguments are same, the first and the last iterator, okay? 2 iterators, everything between that will be sorted, and the third argument is a comparator. Okay, so we have 2 iterators as argument, and the third argument is a comparator. And what is a comparator, we will see. Okay, comparator is basically something that will enable us to modify the sorting technique. Okay, if you want to sort the container in descending order or some other order, okay, of our choice, then we can write it in a comparator function and we can pass the pointer to that function here. Okay, that is very easy. Okay, I'm using big words, but writing that is very easy. We will see what comparators are, how to create comparators, and how to use the second syntax. I hope till now everything is clear. Udit, it is not necessarily that it will use merge sort, okay? You don't know what algorithm the sort function uses. Actually, it might be a mixture of merge sort and quick sort, okay? I tried to learn about it. But so what it does is, you just need to know that it uses the most efficient technique, okay? It is not necessarily the merge sort function. Actually, the randomized quicksort version algorithm also gives n log n every time, okay? So you don't know. Yeah, Kumar, Suyash, I'll answer your query, okay? I'll answer your query. So this particular sort function works with iterators and pointers as well. Instead of iterators, you can pass pointers as well, okay? That's why this sort function works for arrays as well. You can sort arrays using this sort function only. Sort a plus n. You have seen this thing. You might have seen this line, okay? If you want to sort an array, you can use the same function and pass to. So here you can pass pointers as well, okay? Instead of iterators. And it will sort anything between these 2 pointers. That's this is the reason you're able to sort arrays or vectors, okay? Yeah, so we have seen that a random access iterator is like pointer only, okay? So instead of a random access iterator, you can pass a pointer as well. Why? Because it is not a random access iterator, it is just a template. It is just a template, okay? It is a name, random access iterator. You need not pass a random access iterator only, okay? There is no condition. So that's why you can pass pointers as well. So don't think that if a random access iterator is written here, you need to pass a random access iterator only, okay? You can swap this thing with t also, okay? It is just a name. So generally it is used for random access iterator, but people use it for pointers as well. So this function works for pointers as well. You can sort an array as well. Cool. So now let's see the theoretical details about the function. So the sort function sorts the elements in the range first to last. This is very important. This is very important. What is first and last? In the argument, the first iterator and the last iterator, okay? We are passing 2 iterators. The first argument is called the first iterator. It is named as first, and the second argument is named as last, okay? So it will sort everything in this range. So the last element is not included. The last element is not included. Remember this thing, okay? So first is included, but the last is not included. That is why when you write sort v.begin, v.end, actually v.end contains a garbage value, okay? Actually v.end contains a garbage value, we don't know. But that value will not be sorted. It does not sort the last value, okay? That's a round bracket there. So it will sort everything before that only. That's why the entire vector will be sorted when you write this line, and that is why when you write sort a plus n, the entire array is sorted. Actually a plus n does not point to the last element of an array. It is after that, right? What is an array? If a is the array, a points to the first element, a plus n minus 1 points to the last element, but a plus n points to an element after that. That's why we have to pass a plus n, because the last element is not included in the sort function. Cool. So sorts the element in the range first to last in ascending order. So if you use the first syntax, by default it will sort that in ascending order. Okay, sort the array or the vector, anything in ascending order. And the elements are compared using the operator less than. Okay, so this operator less than can be overloaded as well. What happens is, if you're trying to sort objects and objects of some class, okay, let's say I have a class C, and here I have overloaded the operator less than. Okay, for this class C I have overloaded the operator less than, and when I create n objects of this class in a vector, and when I try to sort that vector, okay, what I'm trying to do, I'm trying to create a vector of type C. Okay, you can do that. You can create a vector of objects of a class. Okay, so this vector is of type C, and C is the class, right? You can do that, and you can push many objects into this vector, and when you try to sort this vector, this particular less than function will be used. Okay, the overloaded less than function. So what happens when you call the sort function? It uses the less than operator to compare elements. Okay, any sorting algorithm will compare elements. This is lesser or this is lesser. Okay, it will compare elements. So the less than operator, which is overloaded for objects, will be used. Okay, if it is not overloaded, the default less than operator will be used. So for integers, if you're not overloading the less than operator, it will just compare two integers. Okay, so whatever the less than operator is doing for that object, that will be used for the sort function. Okay, that is what this line means. So the elements are compared using the operator less than for the first version, and so in the first version, in the first syntax, they will be compared using the less than operator, and in the second syntax they will be compared using the comparator. Okay, in the first syntax the elements will be compared using the less than operator by default. Okay, so if it is overloaded, then the overloaded version will be taken, and if it is not overloaded, then the general version will be taken. Okay, but in the second syntax, the elements will not be compared using less than or greater than. They will be compared explicitly using this comparator function. So you can write anything in this comparator function, and that will decide how the elements will be sorted. Okay, Vishal, iterator is of type iterator and pointer is a pointer. Okay, what happens is, you know what pointers are and you know what iterators are. Okay, so iterators are defined to be iterators. So what happens? A random access iterator works like a pointer. Okay, but no other type of iterator is a pointer. Okay, so iterator have many types. Iterator has many types: forward iterator, reverse iterator, bidirectional iterator. A forward iterator is not a pointer. It does not provide all the functionality of a pointer. Okay, so it is a pointer in a restricted way. You can think of it this way. Okay, so iterator are something explicitly created for containers in standard template library. Okay, they are defined in such a way, and only the random access iterator that has all the capabilities provides full functionality of a pointer as well. Okay, so pointer is a superset. Okay, pointer contains many functionalities. Not all iterators provide all these functionalities. Only the random access iterators provide all the functionality of a pointer. You can think of it this way. So worst case complexity is not n square, it is n log n only. Okay, even in worst case the complexity will not go n square, never go n square. Okay, the worst case complexity of the sort function will be n log n only. Even for the merge sort, the worst case complexity is n log n, right? It will use the most efficient algorithm for a particular problem. You don't need to worry about anything. So it is very wrong to use statements like this. They are not subsets of iterators. They are both defined separately. Okay, why do you want to compare them? Pointer is a pointer and iterator is a iterator. Okay, they are defined separately. So why do you want to compare them? Actually, a random access iterator provides all the functionality that the pointer provides. You just need to remember this thing. Okay. But I have told you, you can print a pointer. It will point to the memory location. Okay, so the memory location will be printed, but you cannot print an iterator, what it is containing. Okay, it is an abstract data type. So yeah, so the first version will use the less than operator to compare elements. The second version will use the comparator, whatever you are defining. Whatever you are providing as the argument, that particular comparator will be used to compare elements. Okay, so let's look what a comparator function is. Okay, let's look at that. So what happens? Only the second syntax will use the comparator function. Okay, so if you are using sort v.begin, v.end, if you are just doing this, automatically the first version will be called, okay, with only 2 arguments, and it will be sorted in ascending order using the less than operator. But if you are providing the third argument also, it should be of type function. Okay, it should be a function, so it should be a pointer to a function, and we have seen that the name of the function is a pointer to it. Okay, the name of the function is a pointer to it. So if I write comp here, then comp should be a function that should define the behavior, that which element is less than or which element is greater. Okay, so comparator function are restricted, they should have some functionality, so it should help the sort function and other functions as well. So comparators are very general functions. Okay, they will be used in lower bound binary search everywhere. So the same comparator functions can be used in sorting, lower bound binary search, and all the other functions, all the other generic algorithms. Okay, so let's see what a comparator is. Okay, so comparator must be a binary function. Comparator must be a binary function, and when I say binary function, it means that it should have 2 arguments. Okay, it should have 2 arguments of same type. So it must be a binary function that accepts 2 elements in the range as arguments. It should have 2 arguments. Okay, and returns a value convertible to bool, or you can think of it that as that you should return boolean value. Okay, it should return either true or false. Okay, what a comparator is, it is a function that takes 2 arguments and it should return a boolean value. Okay, so what happens, the value returned indicates whether the element passed as the first argument is considered to go before the second in the specific strict weak or ordering it defines. Okay, what this line means, I'll tell you. So what happens, let's say we have a vector containing these 4 elements, 3, 1, 2, 4. Okay, we have 4 elements in a vector. This is our vector v. So if I use the function sort and just pass v.begin and v.end, what will happen, this vector will be sorted and it will become 1, 2, 3, 4, right, in ascending order. So every sorting algorithm relies on a comparison technique. Okay, every sorting algorithm relies on a comparison technique, and that comparison technique tells you that which element should be placed before and which element should be placed after. Okay, that is sorting, right? You have to sort elements in a row. Okay, so some elements should be at the left side, some elements should be at right side, and that is sorting. Okay, and you should have a criteria for this sorting, and if you don't specify any criteria, what criteria is used? Less than. So the elements which are lesser should be present first, and the elements which are greater should be present last. Okay, this is the general criteria. So if you don't pass anything, less than criteria will be used, which means that the elements which are smaller should be present in the front and the elements which are greater should be present at the last. Now what this comparator function will do is, you can specify some other criteria. Okay, so I don't want that the smaller element should be present in the front. Let's say I want that the larger element should be present at the front. Okay, and it has a name also, descending order sorting. Okay, that I want to sort the elements in descending order. What happens now? What do I want? That the elements which are bigger should be present in the front, and the elements which are smaller should be present at the end. That is what I want. So what the comparison function should look like is, it should have two arguments. That should be of type whatever we are comparing. Okay, so if the vector is of integers, then the two arguments should be integers. Okay, if the vector is of integers, then the two arguments should be integers. If the vector is of characters or strings, the argument should be same. Okay, so the type of vector should match the type of the arguments in the comparator. First thing is this. Now what happens? What will happen? So let's say this element is A and this element is B. Okay, what the algorithm will do inside is, it will pick two elements from the vector or any container. It will pick two elements, and the first element, the one which is present in the left, will be named A, and the element which is present in the right will be named B. Okay, two elements are picked from the container. They are named A and B. So why I'm naming them A and B? So actually the one which is present in the left will be the first argument to the comparator function, and the one which is present in the right will be the second argument to the comparator function. Okay, it will pass those two elements as the first and second argument to the comparator function. Fine, so far so good. It will pick any two elements, it will try to compare it. Okay, so most of the sorting algorithms works on swapping. Okay, so it should compare two elements. Okay, so from the container it picks two elements. The one which is present in the left is passed as the first argument. The one which is present in the right is passed as the second argument to the comparator function. Now if the comparator function returns true, then the value present in the left should stay at left. Okay, so what I am trying to say, so I'll frame it differently. Okay, so okay, think of it as the first and second element of the sorted array. Okay, think of it as the first and second element of the sorted array. You just pass the first and second element of the sorted array to the comparator function. Okay, and if it returns true, then they should stay as it is. Okay, so what happens if you if your initial vector is 3 1 2 4, and if your target vector is 4 3 2 1, then think of it this way: when I pass 4 and 3 to the comparator function, it should return true. Okay, when I pass 4 and 3, 4 as the first argument and 3 as the second argument, it should return true. Okay, so what does this mean? That if the first argument is greater than the second argument, then it should return true. You got my point? So this is the initial vector, this is our target vector. Okay, and what our criteria is, if A is greater than B or the first argument is greater than the second argument in the comparator function, then we have to return true. So what will happen in the target vector that we want, the final target? Okay, just see the first and second elements. Okay, and pass them to the comparator function mentally. Okay, so this will be the first argument, this will be the second argument, and the comparator function should return true if they should remain like this. Okay, so if this is A and this is B, every time we want that if the first argument is greater than the second argument, we should return true. Okay, this is what the descending order sorting is. Okay, this is what the descending order sorting is. If we want ascending order sorting, if we want the final target to be 1 2 3 4, what do we want? If the first argument is less than the second argument, we want to return true. Okay, do you understand the difference? I'll come to greater. Okay, you're using the greater function as it is. I know that it is defined, but sometimes you might not want to use the greater function. Okay, when you want to sort a vector of vector or a vector of pair, very difficult functionalities when you want, you have to write your own comparator function for that. Okay, and then you have to use the comparator function basically. Okay, you have to create your own comparator function. That's why we are learning it. I know that the greater function is already created. We'll discuss that also. Okay, in the next slide, in a couple of slides later, we'll discuss the greater function as well. But we might need to create our own comparator functions as well. Okay, so so the comparator function should return true. So if in the final target you pass the first and second elements as the first and second argument to the comparator function, and it should return true. That's your ultimate goal. Okay, so and for any two elements, okay, for any two elements in the order, this should happen. Okay, you pass 4 and 2 and as first and second argument, it should return true. For any two elements in the final sorted order, the left element if you pass as the first argument and the right element you pass as the second argument, it should return true. Okay, this is your target. So if you want to sort the elements in decreasing order, what should the comparator function look like? Okay, so this is our comparator function for the decreasing case. Okay, so I'm trying to create a comparator function for vector integers, and I want to sort them in decreasing order. Okay, so what do I want? If a is greater than b, I want to return true, else I want to return false. Do you see this thing? This is the comparator function that will be used for sorting a vector in decreasing order. Why? Because you take any vector in decreasing order, and this comparator will return true if you pass the left number as the first argument and any number in the right as the second argument. Okay, so if you got this thing, then just write in the chat box, or else I'll reframe this thing. So how to create a comparator function? Just check your ultimate goal. What do you want? Okay, just check your ultimate goal, and in your ultimate goal, all the you take any pair of values. You take any pair of values. The one present in the left should be passed as the first argument. The one present in right should be passed as the second argument, and every time true should be returned. Okay, and if you pass vice versa, like if you pass the right element as the first argument, and if you pass the left element as the second argument, it should return false. Okay, this is what you want. So for sorting a vector in decreasing order, this should be our comparator function. Okay, all the if a is greater than b, it should be present in the front. Okay, so right now we have not used pointer to the function. Right now we have not used pointers to function and everything. Now what we will do is, now when we want to use the second syntax, we will write like this: sort v dot begin, v dot end, and then in the third argument we will pass pointer to this function, and the name of the function is the pointer to the function. Okay, we just have to write comp. So automatically the comparator function comp will be used to sort the vector v, and this comparator function says that the values which are greater should be present in front. Okay, you can think of it this way also. So if the first argument is greater than the second argument, then this means that the values present in the front should be greater. Okay, so this is like sorting in descending order. So actually these two lines can be written as like this also: return a greater than b. You got this thing? You can write just this statement also. Instead of those two lines, you can just write return a greater than b. You got this thing? Cool. So we'll see one or two examples. So in this example we have not used the second syntax, we have used the first syntax only. So it is easy actually. Okay, what we are trying to do, we have created an integer array. We have created an integer array with these values. This is an array. Okay, and we can create an vector using integer array. How? So this is one of our constructor for vectors. Okay, we can pass two iterators to it. So actually we can pass two pointers also. Okay, we can pass pointers or iterators. So whenever we can pass random access iterators, we can pass pointers as well. Okay, you can think of it this way. So for vectors we have random access iterators, so we can pass pointers as well. So we are passing it two pointers. So this is how you can create a vector using an array. Okay, this is simple. You can create a vector using an array. You just have to pass two pointers. So what is int arr? The name of the array is the pointer to the first memory location. And what is int arr plus 8? This is int arr plus 0. This is int arr plus 1, 2, 3, 4, 5, 6, 7, 8. Okay, this memory location. So everything between first and last will be used. Okay, and not the last. So for standard template libraries, in most of the cases the last element is not included. Okay, that's why end points to one element later. Okay, so the vector will be created using these elements 3, 7, 1, 4, 2, 8, 5, 3. Okay, it will have 8 elements. So now what we have written, sort v.begin and v.begin plus 4. Okay, so do you see this thing that this statement will make this vector as this? Okay, so this is v.begin, this is v.begin plus 1, this is v.begin plus 2, this is v.begin plus 3, and this is v.begin plus 4. And what does the sort function do? It sorts everything between the first element and not the last element. Okay, so 2 is not included. So it will sort everything between 3, 7, 1 and 4. Okay, so it will become 1, 3, 4, 7, 2, 8, 5, 3. So when you pass sort v.begin and v.begin plus 4, initial 4 elements will be sorted. Okay, very easy. Okay, now you understand everything, every little insight of the sort function. It contains two iterators. v.begin is an iterator pointing to the first element. Okay, and this is the iterator pointing to this element. So everything between this will be sorted. And now actually this was already sorted, but this is what we will be using. Okay, sort v.begin, v.end. v.begin points here, v.end points here, one element after it. So everything between this and this, not end, okay, will be sorted. So 1, 2, 3, 4, 5, 6, 7, 8 will be there. Cool, simple. And here is an example using the comparator function. It is also very simple. I have used the same comparator function. What the comparator function should look like? The argument should match the type of the vector. Since the vector v contained integers, the vector v contained integers, so the argument should also be integers. First thing is that. And if I is greater than j, then we have to return true, else we have to return false. Okay, so we can just add return I is greater than j, because this will automatically convert to true or false depending on I is greater than j or not. Okay, so this is the comparator function that we should use if we want to sort in descending order. Okay, so the same function is used for sorting the first 4 elements. So the first 4 elements will be sorted in descending order, and actually you can sort the entire vector also. So here first I have used the fun function. It will sort in descending order, and instead of fun function you can use the predefined greater object as well. Okay, greater is not a function, even though it looks like a function. It is not a function, it is an object. Okay, we will see that. When you write like this, greater is actually a class and you are creating an object of it, and this particular operator round brackets is overloaded for this class. So it looks like a function, but actually it is an object. Okay, it is very complicated. You don't need to understand it fully. Okay, if you understand it fully then it is fine, but you can think of greater as a function as well, but it is an object. Okay, you are creating an object of the greater class. Greater is a class template. Okay, you are creating an object of it, and the round brackets are overloaded in this class, and so it looks like a function. Okay, so the functionality of this function fun and this greater is same. Okay, so you need not create this function fun for sorting in descending order. For sorting in descending order you can always use the greater object. What you have to do, just write the type here, the same type, the type of the vector. If it is a vector of vector, just write vector here. Okay, if it is vector of pair, just write pair here. So whatever the functionality it originally has, so now what happens, not the less than function, now the greater than operator will be used to sort. Okay, what this greater function does, that the less than operator will not be used to sort, instead the greater than operator will be used to sort the vector or any container. Okay, so so this greater object already contains the implementation of this fun which we have written here. So okay, so let's continue with the greater class template. So we had also one more lecture, so I thought that this content will be finished in 45 minutes, but it will take some time. Okay, so we'll continue sorting only till 9 p.m. Or we'll start that in 15 minutes. Okay, I'll finish this quickly and then we'll start the next lecture, which is upper bound and lower bound. Okay, so that session will be delayed. Someone please comment in that chat box. Okay, if someone is waiting, just comment that it will start in 10-15 minutes. Let's continue it here only. Cool. So yeah, let's see the greater class template. So greater is a class template. It is not a function. It looks like a function, but it is not a function. It is a class template in which round brackets is overloaded. Okay, simple. So yeah, it is a class template and it inherits some binary function named class. You don't need to see what a binary function class is. It inherits a binary function class. How it does that? It is not the scope of this course. Okay, this is too much detail. You don't need to explain. I don't need to explain this thing. You don't need that in competitive programming. Okay, so you just need to see this thing, that in this class the operator round brackets is overloaded, and it is overloaded in the same way. It contains two arguments of type t. It contains two arguments of type t, and it returns x greater than y. Okay, so the implementation of greater is same as the function fun which we were talking about. Okay, you just need to remember this thing. Okay, you can try to learn it. If you want me to teach the binary function thing, I can do that. Just write in the chat box. Maybe I can create one more video if you want to understand what this binary function class is and how exactly the greater function is implemented internally, but it will not be required. Okay, okay, so what do you know now? You don't need to create this function, the comparator function, for if you want to sort in descending order. Only if you want some specific details. For example, you have a vector of pairs like 1, 2, 3, 7. We can have pairs also. Okay, these are pairs. Okay, we can have pairs, and we can have vector of pairs. Okay, an array of pairs like this, and we want to sort this entire vector based on the second element. So for this you have to create a comparator function. Okay, you have to create a comparator function which will take two pairs and it will return the second value for the first pair is less than second value of the second pair. We will see that. Okay, now you know how to create a comparator. When we finish pair, this will be easy. Okay, so I have seen many people struggling with this thing. When you have triplet of vectors, vector of vector, how to sort them on the basis of second element, third element, how to sort them in descending order, it will be very easy. Okay, you just have to create a comparator function intelligently. That's it. Cool. So this is about greater, and the next thing is stable sort. Okay, so if you know algorithms, you might know that what a stable sorting algorithm is. Okay, so what happens is, if you have two ones, or let's say we have two 2s. Okay, this is our array, this is our vector, and we want to sort it. So the sorted vector will contain something like this. So what do we want is the one which is present before should be present before. This is stable sorting. Okay, so even if the value matches, the one which is present before should be present before. Okay, this will be stable sort. Okay, so I hope you understood this. It will not be clear when we have just a vector of integers. Okay, it doesn't matter, both are one, right? So but when we have a vector of pairs, what happens is when we want to sort this vector of pairs, it might be the case, so if we are sorting it using the first value, the first value of the pair, it might be the case that this is also a correct sorting order, and actually this is also a correct sorting order, right? Because according to the first value, this vector is also sorted. Okay, but originally if the vector was like this, you want the final vector to be also like this. Okay, the one value which is present before should be present before if the value matches. Okay, this is called stable sorting. So the sort function here does not guarantee stable sorting. Okay, that's the only difference. It does not guarantee stable sorting. So what happens? It might shuffle the elements. If the values match, it might shuffle them. You don't know. The internal algorithm might shuffle them. Okay, but if you explicitly write stable sort, everything will be same. Okay, both the syntaxes are same. Both the syntaxes are same, exactly same, but just you have to write the word stable sort instead of sort. Okay, so this function will be useful when you have vector of vector or vector of pair or vector of triplets, something like that. Okay, there stable sorting will be useful because you want to preserve the initial ordering if the values match. Fine. So yeah, so everything else is same. It also takes n log n operations in worst case. Okay, so so you should use stable sort instead of sort, but actually it requires a little bit more memory. Okay, as compared to sorting. The normal sorting. Okay, so but it doesn't affect our codes. You can use stable sort as well, and we will be using it. So that's the only difference between sort and stable sort. Okay, so if you understood everything in this lecture which I have told, just write in the chat box. Okay, I think sort, the greater and the comparator function and stable sort is clear. Okay, the stable sort will also have two versions, one without the comparator and one with the comparator. Okay. Actually, Nikhil, it requires lesser memory. Okay, so it is saying that if you are using a stable sort and if you have no other memory, okay, if you have no other memory present, then stable sort will take n log square n time, or n log n. Okay, n log n into log n, n log square time. Okay, it will be more than simple sorting. But actually we have little bit of memory, little bit more memory in general cases, so we don't see the difference. So the time complexity will be same, but actually it takes little bit more time if you have no other memory present, the stable sort. That's why we are not depreciating the initial sort function, and that's why we have both the versions of sort and stable sort. Okay, this was my doubt also, that you should write the same code in the sort function. Okay, we should not have two separate versions. But if you don't have any additional memory, this particular stable sort will take a little bit more time. Okay, fine. So yeah, this is the Telegram group. If you have not joined, you can join it. Let's meet in the next lecture, which is binary search and lower bound and upper bound. Okay, that will be also very important. Sort, binary search, upper bound, lower bound, we will be using very extensively in competitive programming. Okay, so you don't want to write the binary search again and again for every problem, right? You just have to write one line and things will be done. So the correct implementation you should know. So let's look at that. Okay, so let's meet after 5 minutes. Okay, if you have you can just chat in the chat box if someone is waiting. I'll join that meeting after 5 minutes. Bye.